Okay, let's keep going. Hopefully you just finished the other video where I can just keep moving along. If you need to refresh that, if it's been a while, go back and look at it. And let's apply these concepts from the key concept to the question starting at number 21. Here we have a fraction, exponent, a to the 1/6. Going back to the rule we learned up here, where the numerator is the power in the radicand, and the n is the index. Well, the 6 is the denominator, so that goes here. So it's like 6 times the 6th root of a to the power of 1. See the 1 over 6. 1 over 6. Number 2, x to the 1 over 3. Okay, the numerator is 1. The index is the denominator, 3, the cubed root of x in that case right here. And number 23, the same thing. Denominator goes here, and inside the radicand, they left the whole thing blank, so we'll just call that the cubed root of y. When it's power of 1, you don't need to write it on there. So in number 24, when we have a to the power of 5/6, notice we have a to the 5th in there. Okay, the numerator is that power on the a, the 6th root of a to the 5th. And then the last question right here. Now look at that. That's 5 to the power of 1/3. Think of that again. It's 5 to the 1st times x to the 1/3. So that's why the 5 is outside the square root, and it's x to the 1. The index is 3. 5 times the cubed root. Now that's not 5 to the 3rd. Okay, it's 5 times the cubed root of x. Okay, don't be confused on how I wrote that there. That is not 5 to the 3rd there. That is actually the answer. 5 times the cubed root of x. Okay, so hopefully you're able to follow that. It all comes back to this rule right here, and I think if you understand the uh, a to the m over n and how it compares to that, your life will be easier. Okay, this next question I'm not a big fan of, so I'm not going to make you do that. Something really weird happens with this 54, and we actually will get into that idea when we get later in the year when we talk about simplest radical form, getting you ready for geometry. Okay, so skip 26 and 27 and let's move right along. This I would expect you to be able to answer. Converting to exponential form. Okay, it says write each radical expression in exponential form. And here's the examples they're going to walk us through right here. So number 28, you have the cubed root of s to the power of 2. Well, the first thing you need to do is identify the index is 3 and the exponent of the radicand is 2. All right, and we'll see what to do with that in just a little bit. All right, number 29. In this question, the index is 3 and the exponent is 4. And then on this one, the index, what is that index right there? If it's not written, that's one of the rare times. If it's not written, it's actually 2. It's a square root. And the index on the radicand, on the y at least, is a 5. So that takes us to number 31. It says underline the correct word to complete each sentence. The index of a radical is the blank numerator or denominator. The index we look up here if you forgot. All right, that index, remember it would be 2/3, 2 over 3. So the index is actually the denominator of the exponent. The exponent of the radicand is the numerator right there. Okay, so here's what I mean by that. If you want to put that example again, s to the 2/3, that first example is equal to 3 square root s squared. Those are the same thing for you. So I actually think we're going to answer that on the bottom of the page here. I got a little bit ahead of myself, so let's do that here. That is, we just said, that's s to the 2/3. Okay, the exponent on the radicand is the numerator, and that's a fraction exponent. I know I didn't write it real well because I can't write too small here. This particular problem, that's the numerator is the 4, so that would be x to the power of 4 over 3 right there. This one, that's 5 over 2. And since the parenthesis is around the 4, we'll put the parenthesis around the 4 in that particular problem as well. So hopefully that makes sense to you. So it says what number multiplied times itself has the product of 256, and I already know what that is. What you might try on your calculator is try that the 4th root of 256 and see if you get the same answer as I got, which was 4. Okay. Number 37 says circle the expression that shows the fourth root of 8 times the fourth root of a to the power of 8 written in exponential form. And we have that, let's see, right, well, it's not this because that actually equals a to the fourth, right? Because it's being divided with the same base, so it's not that. It looks like it's this one right here because you have 8, 4. Let's take a look at the last answer, 4 over 8. Nope, that's switched around, so it is the middle one right there, which is really, I guess, a to the power of 2, which you could do that as well. Writing this problem in exponential form, that one actually does work out because the fourth root of 256 is equal to 4, which I showed you up there. And then so you have basically 4 times a squared, because a to the 8 over 4 is equal to a squared. So they kind of worked you through that question right there. So that's how you would solve this problem right here. Use your we'll get to where we're just using our calculator to evaluate, but you should understand the concept that index is telling me that many factors of that number to get to the solution there. Hopefully that makes sense to you. And moving along to the back here, here's a really cool science application for us. It's really a simple problem if you have a calculator, and it says that you can estimate the metabolic rate of living organisms based on body mass using something called Kleber's law. And here's the formula. And the formula relates the metabolic rate, which we're going to use R, measured in calories per day compared to your body mass, which we'll use M, that's measured in kilograms. What's the metabolic rate of a man that has a body mass of 75 kilograms? So we have someone who weighs 75 kilograms. We can plug it into this formula and calculate the solution here, the metabolic rate of living organisms, which is R. Here we go. So it says write the number to complete each step. Okay, so here's the formula. R equals, just taking it from right here. Might not understand what it all means, but if they give you a formula, we can apply it. That's what we do in algebra. R is equal to 73.3 times the fourth root of whatever M is, which is 75, to the power of 3. And basically at this point, you're doing this on your calculator now. So I'd like you to try. See if you can take this times, and then you input that as 1. If you're having issues on your calculator, you could put all of that in parentheses there, and then see if you come out. I came out with 1868.099, and there's a whole bunch of numbers. It looks like it's irrational. If we round it off to the nearest calorie, it comes out to be 1868. Round it off to the nearest calorie because that's a 0 right there. Drops the decimal value for us. So, quick wrap up here. I'm going to skip down, I think, to I'm going to skip this one and number 42 because this is what I want you to be able to do. If we have this, okay, if we just use what we learned earlier, you would write that in exponent form, a to the m over n. If we had this one right here, that would be a to the b over c. All right, now it says write the radical expressions using the exponents. Then it says multiply the expressions. So if I have a to the m over n times a to the b over c, what's the rule when I multiply exponents with the same base? The rule is you add the exponents. So that's m over n plus b over c. Now, since those are variables that are not like, that's really the only thing you can do with that. So what we did is we used both the product multiplying exponents property as well as the exponent rules we learned here today. So that's all you need to do. Don't worry about 43. That's the main idea. And the things that I emphasized here is what I will be looking at that you're able to do as we progress. So I hope that works for you. And we will talk to you soon.